with it, thought that it was a spell. I ain't say come, but see at the hotel. Fucking nigga, me.
Oh hi, didn't see you there. My name is Ubaldo, an expert in procrastination, and today I'm going to teach you about the best gas law that you can ever find. Chalk. Do you know anything about gases?
No.
Do you think gas laws are important to daily life?
Of course.
Well, today I'm going to teach you the essentials of Charles' law. This law was created in 1790 by a physicist which name was Joseph Charles. What he did? Well, he made a series of books that were never published, and it was until 1802 when Joseph Louis Gay-Lussac gave him recognition about his works. But what did he do? What did he state? Well, he said that for a fixed mass at constant pressure, the volume is directly proportional to the temperature in Kelvin. Well, what does this mean? Okay, I'm going to teach you about what does this mean, okay? When the volume increases of a gas, also the temperature increases because it's directly proportional. I'm going to give you an example. Imagine that you have a gas at a certain volume, and you increase it at a double size. Well, the temperature will also increase at a double. Why? Because it's proportional. Also, this states that when you increase the temperature of a gas at a certain container, the particles of the gas will move faster. How could you calculate it? Well, you can calculate it by using the formula V1 over T1. What does the letters mean? V means volume, T temperature, and this is going to give a constant. This is also a linear equation. The relation is linear, and also this can be applied in real life.
The hypothesis of this experiment is that if we apply the enough and the required temperature, the volume or the size of the balloon will actually increase. For this experiment, what we are going to need are a volunteer, a beaker, a Bunsen burner, a balloon, and a certain amount of water. For the variable identification, we put as an independent variable the air or the pressure that the balloon is actually going to hold. Then as a dependent variable, we have the actual size of the balloon, like the increasing size, and the control group is the temperature that it's going to be provided by the Bunsen burner / aka the thing that it's going to heat up our substance, that which is the water.
And now let's go visit the lab.
Step number 1 is to fill up a balloon into a medium size. Step number 2 is to place boiling water in a beaker and then let it set. Step number 3 is to place that balloon inside the beaker and then place a plate on the top of that beaker in order that air cannot escape. And step number 4 is to watch how the volume of that balloon increases.
In our experiment, our balloon is filled with gaseous air molecules. When the balloon is placed in the beaker with boiling water, the energy from the higher temperature water and steam molecules transfer to the lower temperature air molecules inside our balloon, exciting them. When the air molecules in our balloon are excited by raising their temperature, they spread further and further apart, increasing the volume of space they take up. The higher the temperature or the more energy the air molecules get, the larger our balloon will grow, or in other words, the greater the volume of space our gas will take up. If we remove our balloon from the hot water, the air molecules inside our balloon will gradually lose the energy they've been given, dropping back to room temperature, causing the balloon to shrink in volume back to its original size.
The results that we could observe after we placed the balloon inside the beaker and put a lid on it so the heat wouldn't escape was that the balloon started to inflate because of the high temperature that causes the volume of the gases to increase. So the balloon started to inflate and it touched the walls and pressed against the walls of the beaker. And after we took the balloon out of the beaker, because of the lower temperature that was the room temperature, the balloon inflated a little bit.
According to the experiment made by the science guys, we gotta have a constant or stable temperature and pressure for the Charles law to be represented.
By changing the temperature of our balloon, we can clearly see the directly proportional relationship between the temperature and volume of an ideal gas. This relationship is known as Charles' law.
In our experiment, we indeed changed the conditions of the temperature, and the pressure changed too, and we made the Charles law.
As a conclusion, we can say that our hypothesis was correct because when we introduced the balloon into the hot boiling water and partially submerged it, the volume of the gases inside it started to increase, and so the balloon inflated because of the increase of the temperature that causes an increase in the volume. Also, when we took the balloon out of the beaker with the boiling water and the temperature was considerably lower than inside the beaker, we could observe how the volume of the balloon decreased and the balloon deflated.